Okay, so we're going to begin with Chapter 4 today, and we're going to talk about development through the lifespan. So this chapter is going to take us from conception to death and everything in between. We're going to talk about cognitive development, social development, and biological development. So let's start at the very beginning, conception. So on the far left you see an egg being swarmed by a bunch of sperm. This is a pretty good depiction of how many sperm tend to make it to the egg in real life in the actual natural conception. In conception, when a man ejaculates, he leaves 250,000 to 500,000 sperm that then start swimming and trying to find their way to the egg. So you've got this gigantic number of sperm that some of them aren't properly formed, so they don't even make it up the reproductive tract at all. Some lose steam halfway up and they don't have enough nutrition in their little nutrition packet on the head of the sperm. Some go the wrong direction, some spin around in circles and try and impregnate epithelial cells and other kinds of things. At the top of the uterus there are two fallopian tubes for the sperm to choose from. Half of them go up one fallopian tube, half of them go up the other one. There's only an egg in one of those fallopian tubes. New research shows that there's actually probably not half and half, that the egg actually sends out a little impulse that attracts the sperm toward the correct fallopian tube and boosts the probability that the sperm will go up the right fallopian tube. But at every step along the way, oh, and I forgot to mention, all along the way the female body is attacking the sperm because it's foreign, and so she's mustering her white blood cells and little soldiers to come out and kill the sperm. So it's all a very rough journey for the sperm, and usually out of that 250,000 to 500,000 sperm that were deposited, about 50 of them make it to the egg. Of the 50 that make it to the egg, one and only one will be able to pierce the outer shell of the egg and share the DNA so that you can create a new cell. By the way, eggs carry half of mom's DNA. Mom's DNA is lined up in pairs, and when an egg is created, randomly from each of those pairs, one side is chosen. Dad's sperm, same way. He's got half the DNA. So when the sperm and the egg combine, they make a new intact cell that has all 23 pairs of chromosomes. Alright, so conception has occurred. Now everything we're going to talk about here is going to occur prior to birth. So it's called prenatal, prior to birth. Okay, so the zygote stage is between conception and then about 10 to 14 days after conception. During this stage you have a single fertilized cell that starts to replicate, and it goes from 1 cell to 2 cells to 4 cells to 8 cells to 16, and I won't test my ability to keep doubling all the way until it becomes actually a blastocyst. At 100 cells it becomes a blastocyst. Once it's a blastocyst, then it can implant in the uterine lining, and then it becomes an embryo. So the embryonic stage is going to be from about 14 days to about 8 weeks. So here we have a little 8-week-old embryo on the left, and you can see it's not very well developed at 8 weeks, is it? If you look closely, and again, I'm not sure if you can see my mouse, but just in case you can, I'll point at things. Otherwise, I'll try and verbally describe it. We'll start at the top, which is the curled over part that kind of looks like a walrus's head. If you look closely, you can see the little shadow of what's going to become an eye. And if you notice, it's way on the side of the head, and that's going to be really relevant later. You can also see the beginning of what will become an ear, and it's way down low on the neck area and is really more of a gill than anything else at this stage. Fluid can pass through it and stuff like that. The nose is up here on the top of the head in the position of a blowhole. So all of your facial structures are not in their correct place at 8 weeks after conception. Things that are really recognizable would be like the spinal column. You can see the vertebra. Right now they're cartilage. They're not really bone, but you can see it starting to develop. In fact, at the beginning, probably 3 weeks prior to this picture was taken, you've got basically a brain stem and spinal cord, and then this other stuff grew around it. Other stuff that includes this red structure, which is the heart, and this white structure that's ultimately going to become the lungs. You can see this little flipper. That's going to become an arm. No flippers down here at the bottom yet, no feet or legs developing. So the structures are all very basic at 8 weeks after conception. By 9 weeks, look at what has happened in 1 week of development. I don't even have to use my mouse to point things out, do I? You can see the eye, that dark spot. You can see the ear, which is directly laterally adjacent to the eye, which is not where your ears are. If you feel your face, your ears are lower. So things move around still. You can see that big bulbous head on top. Starting to get a little face. And you can see ribs in this picture. You can see the ribs, and inside of it you can see the darkness of the liver. You can see that whereas at 8 weeks there had been a tail that extended past what will become the body, his body's grown up and surrounded the tail. Got a little leg and some feet going on here. Umbilical cord, placenta, and then this fluid-filled sac, which is the amniotic sac, is visible in this picture. Of course, at the 8 weeks there was an amniotic sac also, it wasn't in the picture. So a lot of changes have occurred in just 1 week, right? From 8 weeks to 38 weeks, that begins the period of the fetus. So for most of pregnancy, the future baby is called a fetus. Okay, here we have 7 more weeks of development, and now you can see all the body parts. You can see arms, legs, toes, fingernails are present, eyelids are present, little eyebrows, the nose is where it belongs, the lips are there, right? You can see all the structures are present. From 6 weeks on, the big thing that's going to be going on, 16 weeks on, big thing that's going to be going on is brain development. And the baby just needs to get bigger. At 16 weeks, this baby is approximately 1 inch long. It just has all of its parts in place. So it's a perfect little, perfectly formed body, teeny tiny, and then so it needs to grow another probably 6 3/4 pounds. Needs to be added to its weight. It needs to get another 19 inches longer. Just needs to get way bigger. And then also it needs to, a lot of brain development needs to be going on prior to birth. So a lot of things going on. If we look at the 9-week fetus, where you can clearly see the black of the eye, and you look at the 16-week fetus, you can see the difference in the position of the eyes. The eyes have to migrate from the sides of the head to the front of the face. If a mom consumes alcohol during this critical period of facial migration, she can produce a baby who has evidence in his face that he was exposed to alcohol. It's called fetal alcohol syndrome, when you can see these facial features where the ears are too low, the eyes are too far on the sides, the nose is too high. These are facial features that go along with moms having consumed too much alcohol during this critical period of development. Alcohol, therefore, is what we call a teratogen. It's damaging to the healthy development of a fetus. The key thing with alcohol, it's quite a, wives' tale, that any amount of alcohol will, by definition, harm a developing fetus. That's not known. That's not true. Part of our problem in understanding how much alcohol it would take for a baby to be harmed by it is that moms who give birth to babies who have evidence of fetal alcohol syndrome aren't always honest about how much they have drunk over the course of their pregnancy. Sometimes they are drunk at delivery. Sometimes they've used other substances during their pregnancy, so it's really unclear which one was the critical factor in developing fetal alcohol syndrome. So it's really difficult to tell. Some doctors, in fact, think that it's beneficial for moms to consume up to the equivalent of 1 ounce of alcohol in a day. So that would be like a 5-ounce glass of wine, like that. But others just say, you know what, don't risk it and don't consume any alcohol. A lot of moms, it's sort of a lot of non-alcoholic moms, it's a sort of self-preserving effect where they don't want to drink any alcohol while they're pregnant. They literally, it nauseates them to think about it. So it sort of protects the fetus naturally that way. But we don't know how much alcohol it takes, and so for most moms, they just go ahead and say, I'm not going to drink anything from the time I know I'm pregnant on. Okay, the final stage of prenatal development, well, it ends with birth. Now we're into the neonatal period. So the baby's born. He looks like he enjoyed the process. Actually, this is a baby getting a bath, so it's probably a little older than just freshly born, but I just thought that was a classic, very young baby, no teeth, bright red crying, nice young baby. A lot of people think that babies are born sort of like little puppies, and they don't understand what's being said around them. They don't recognize their parents. They're just sort of like little blobs. But now we realize that babies are born with a lot of innate skills. We call these instincts or reflexes. Here we have a baby who's nursing, and a full-term baby knows how to get food, knows how to find it, breathe while they're consuming it, swallow it without throwing up, stuff like that. These are reflexes. Now it's really important to realize that reflexes are not learned. They are inborn. So some babies who are born significantly preterm may not display these skills because there's some brain development that has to occur for babies to have these reflexes in place. Babies do not learn to want to eat. Babies do not learn to search for food, things like that. This is innate. So we have certain reflexes at birth that help to ensure that we're going to be fed. So what are they? Well, we've got the rooting reflex. If you tickle a newborn up to about 6 or 8 weeks of life, if you tickle the baby on the corner of their mouth, and the younger the baby, the farther away you can tickle and still get the same reflex. So like a newborn, you can tickle as far away as like their ear. And they'll turn their face toward the tickle and root around with their mouth. They're looking for a nipple. So if anything lands in their mouth, they'll assume it's a nipple and treat it as such. So if it is a nipple, if it's a bottle, if it's a pacifier, a finger, they will root, and then they'll display the next reflex, which is sucking. And they will suck on it like they're trying to get food out of it. Newborn babies' sucking strategies are different from adult sucking strategies. A newborn baby will take their tongue, clamp that object, whatever has landed in their mouth, up against the roof of their mouth, and then they work their jaw forward and backward. And that's the most efficient way to get milk out of a mom. It feels really weird on a finger. And if you can watch a baby who has one of those pacifiers that has the hole in the bottom of it so you can kind of see their mouth working, you really can see them displaying that newborn sucking reflex. It isn't until we get older that we start to learn other sucking strategies like sucking through a straw and stuff like that. Another reflex that newborns have that ensures that they get fed is they cry when their stomachs get empty. And they don't cry in a pleasant way. They produce a sound that is designed to make the adults around them want it to stop. It's like, what can I do to make this crying stop? It's very effective. Ensures that mom and dad or caretaker will do whatever it takes to try and make that crying stop. And if it's hunger, then they'll get fed. So those are what we call adaptive reflexes. These are reflexes that help to ensure that this baby's going to survive. There are other reflexes that are not useful anymore. They seem to be evolutionary throwbacks to maybe a way earlier phase of human development. So for example, the startle reflex. If you want to see a baby actually demonstrating the startle reflex, you can look at the PowerPoint slides in slideshow format, click on the Moro link, and it'll show you an actual baby doing it. But I've got you a picture here, and if you've ever picked up a newborn, people always say, now support his head. And the assumption is that it's because it's going to hurt the baby's neck if you let it loll back or something. It's not really going to hurt the baby's neck. They've actually got pretty strong necks. And their heads pretty much just sit on their shoulders anyway, so it's not like they have a skinny little neck really at birth. The key thing is if you let the baby's head fall back, they'll do this startle reflex where, see how he's flung his arms out and his fingers are all splayed and he's pulled his knees up towards his stomach. At the same time, you can't tell, but he's sucking in his mouth at the same time. This startle reflex happens whenever their heads start to drop. Now, maybe millennia ago when moms used to be covered with hair, this might have been a beneficial strategy. If mom starts to drop him, he throws his arms out and maybe grasps his fingers and tries to get into her hair, sucks his mouth in really hard, so if her nipple's in his mouth, he has one last chance to not fall out of the tree that presumably our ancestors might have been sleeping in. But modern babies, this is not a helpful strategy at all. This has got to be a throwback, because if any of you have ever gone in the middle of the night to fetch a crying newborn, you know it is not helpful that they do this startle reflex if you let their head shift at all. You almost drop them. It's 3 o'clock in the morning, you're in the dark, you're kind of tired, and then they throw their arms and legs out and you almost drop them, because modern baby moms are not covered in hair. Modern moms are trying to hold their babies by their bodies. So this is not helpful anymore. In fact, it might be disadvantageous in modern babies. Stepping reflex has no known purpose. Babies can't walk. Again, if you want to watch a baby doing it, you can click on that link in the slideshow. But if you hold a newborn up and support his weight with your hands, and then push his little feet down on something firm like a table, or with a book held in your lap or something like that, it doesn't work on your soft lap. It needs to be something hard. Push their little feet down so that it stretches out their Achilles tendon. They'll start to alternate in this really jerky stepping motion. Right foot, left foot, right foot, left foot, and they can't help it. They do it. Now obviously this baby needs to be completely supported. You can't let go of him and have him keep stepping. It's some people think a throwback to when babies used to be more like other herd animals who have to get up and follow mom right after birth, but that our babies, over the past thousands of years haven't needed to do that, and so they can't really step, but they still can go through the motions of it. It's a weird thing that babies can do. If you know any newborns, you can put them through these little tests. It's kind of fun. Grasping reflex. Again, I've got a link if you want to watch a video of a baby grasping, but you can see in this picture, see how white the baby's knuckles are? He's grabbing on so hard to that finger. Newborns have ninja strength. You can lift a baby up by their own grasp and hold them off the table, and they can hold themselves up. Again, some people think this might be a throwback to when moms used to be covered with hair, and baby humans would be like modern baby monkeys who have to hold on to their mommies from the front and dig in with the hair on the back so mom could walk around on all fours. I don't know if that's true, but it's pretty weird that newborn babies can grab onto anything that's placed in their hand with this vice-like death grip. Okay. The last thing I wanted to say about newborns is that one of the ways that we can tell what babies like and what babies know is through using habituation tests. So here's an example of a habituation test that's been done on newborns. They show the item on the left and the item on the right. Okay, now if you look at that one on the left, it vaguely looks like a human face, right? It vaguely looks like eyes and a mouth with the properly shaped face. The one on the right does not look like a human face. Well, it turns out newborns will stare longer at the one on the left, implying that babies prefer human faces over other objects. So even though we can't ask them questions or give them a survey, we can kind of, and they can't talk or anything, but we can kind of figure out what they know, what they like, what they prefer, based on what do they stare at longer. Another habituation test is to put a pacifier in their mouth that has a wire that goes to a computer that can collect data about how often the baby is sucking on the pacifier. And babies who are like something, who are comforted by something, will suck more reliably on that pacifier, and ones who are startled or uncomfortable will stop sucking. So habituation tests allow us to tell what babies prefer. So saying that, we know that babies prefer human faces through these kinds of habituation tests. Okay, let's go ahead and stop here, and I will come back in the next segment and talk about some of these social capabilities of the newborn.